are there 50%. Okay, because you see CH triple bond CH is there, right? So what you are going to find is, student, this is the hybridization is what is this is sp hybridization because triple bond is there. Now you see s a percentage s if you are calculating. So what is that is number of s orbital. This is going to be number of s orbital divided by total orbital. Total orbital, and that we have to multiply by what is going to be 100. So number of s orbital 1 and total orbital 2 multiply by 100. So it is going to come how many percentage, student? This is going to up acidity, acidic strength. If you see acidic strength, so acidic strength proportional to percentage S current, percentage S current, right? So here you see, if I will see the CH3, CH3, then we can go CH2 double bond CH2, and then we can go CH triple bond CH. In all the cases, what you are finding here, percentage is correct 25%. Here is here if you talk about 33.3%, and here is the 50%. So acidic strength proportional to S character. So you are going to get this is the order of acidic strength, right? Now let us move out the next point. What we can do, it's reaction. What which reaction is going to satisfy the acidic strength? So reaction one. We are talking about reaction one with sodium metal. With sodium metal. Now, student, what is happening? These alkynes are reacting with the sodium metal. This is CH, triple bond CH. And if you are treating with the sodium metal, what is going to happen here? CH, triple bond CNA. Okay, this is minus, this is plus, plus half mole of hydrogen gas. This. So, anything which are reacting with the metal and releasing hydrogen gas, that's going to be acidic in nature. Suppose you are taking the HCl, and what is happening, you are treating with the Na, so it is going to be giving salt plus hydrogen gas, half mole hydrogen gas. So this is the HCl is what is acidic in nature. So similarly this also becomes the acidic with sodamide. Second reaction we are talking about with sodamide. With sodamide, so you can treat these things with the sodamide also, and it will give what ammonia will release. So here is CH triple bond, it is going to be CH, and then you are treating with the sodamide, NaNH2. This is what is going to be, student, sodamide. Here, what the compound you are going to get? CH triple bond CNA plus NH2. So this is the salt is getting formed now, student. That is what is the explaining that it is the acidic in nature. This is what the point we are having. Now, what we are going to do? We are going to write the condition. What the condition you can see, student? No condition. Condition they are saying only terminal alkynes. Only terminal alkynes are alkynes are all alkynes are not acidic in nature. Why? Let me tell you with the help of the example, student. What example you can find? Suppose we are having CH. This is the C and triple bond C and CH3. Where is no acidic hydrogen. And similarly, if you are having CH3, CH2, C, triple bond C, right? So this is the terminal alkyne. This is the terminal alkyne. Terminal alkyne. Terminal alkynes are acidic. So this is the acidic order. It will be acidic. It is almost non-acidic. It is not going to be acidic. This is one of them. Right. Now, if you see the some other point, types of no reaction. If you see the types of reaction, what type of reaction you are going to get? The first one you are going to get addition. Addition reaction. So addition reaction is 99% it gives the addition reaction only. And second point it is going to give, that is ozonolysis. This is the ozonolysis. Okay, ozonolysis. Third one, if you see this, although they are not the addition only, cyclic polymerization. Cyclic polymerization. They are the major categories of the reaction. Now you see the addition reaction. You can add the many things to it. What you can add? You can add the H2, X2, HX, H2O, HOCl. Okay, and you can many more things also you can add. Right. So these are the like that. Here is H2. We can take the palladides alcohol PDC. Okay, this is, or we can take H2, sodium in liquid ammonia. Okay, so they are the type of reaction, student, that is being given by the, what you can say, uh, alkynes. Okay, so let me try to teach you some of the methods. Okay, what we are going to find. Let me tell you the first one: addition of hydrogen. Addition of hydrogen. So it gives a complete reduction. Complete reduction. Okay. Here I am talking about case one with what we are doing, H2Ni gives, what is going to give, student, gives alkanes. This is going to give alkanes. See here, we are having CH triple bond CH, and then we are using H2 in presence of PT, or you can say PD, or you can say Ni. Here one hydrogen, this is, so it is going to give the alkene, student. Alkene. Again, you are one more equivalent you take, student, and same catalyst, PT, PD, Ni, anyone you can take, one here and another here. So it is going to give what, student? This is going to give ethane. This is ethane. Right. Now, what is the case two? Case two. So we are talking about in case two, sodium in liquid ammonia. Sodium by sodium in liquid ammonia. Liquid ammonia. These things we are taking. Sodium in liquid ammonia, it gives trans alkene. Which is student? Trans alkene, not the cis alkene. Trans alkene. Suppose we are having a student CH3, C. This is, we are talking about C and CH3. And you are treating with what? You are treating with the sodium in liquid ammonia. How can you do this one, sodium in liquid ammonia? You just add the hydrogen, and here is the sodium in liquid NH3 is there. So what is going to happen? One hydrogen from the up, another hydrogen from the bottom. So here similar group are to opposite x, no, 180 degrees. Now you can see here, student, this is, so similar group are opposite side. So this is going to be trans bute, that is 2 trans bute. Right. So you can understand very clearly this one. Now the, we are going for the case 3, students. Case 3. Let me see the case 3. Case 3, how can you do? With pitch reduction. Okay, pitch reduction. Pitch. Not a bridge. No, no, no. Pitch reduction, already the sodium in liquid ammonia is there. With, we can go with the Lindelar catalyst. Okay, with Lindelar catalyst. What is Lindelar catalyst, student? Palladides charcoal in quinoline. Quinoline. What is the quinoline, student? This is the quinoline structure of quinoline. This is the nitrogen. Here is the bond. Quinoline actually catalytic poison, which decrease the reactivity of the alkene, so that the alkynes, reactivity of alkynes. Okay, so that complete reduction does not take place, and it gives the what? Incomplete reduction, student. Incomplete reduction in the sense alkane will not form. Here, what is going to form, student? In this case, if you see the alkene only form. And here, if you are Lindelar catalyst, if you are using, it is going to give what? This is the cis alkene. This is going to be cis alkene. So let us see here what we are having. CH3, this is C, this is the triple bond C, and CH3 is there. And here is the hydrogen you are using. This is we are having palletized charcoal, PTC. So both the hydrogen will go from the same side. It is there. So it means the here is the what the reaction you are the product you are going to get student. Here is hydrogen. This is again hydrogen. So one, two, three, and four. So this is what is student six, bute, two, and E. This is what is our required product. So total three cases we study student. What are the cases which we study student that you can see? How can we do back space? Is also the problem. Huh. This one you see. So case one. Case one you are taking the H2Ni. So it gives complete reduction student. Complete reduction. H2Ni complete reduction. So it the product what we are going to get here is student that is the alkane. In another case what we are having is student other case if you see here that is the sodium in liquid ammonia. This is what is called student Birch reduction. This is Birch reduction. You need to keep in mind Birch reduction. So it will give the what student similar group opposite side 180 degrees. So this is what student trans one. Next one, the last case we study here, case number three, Lindlar catalyst, pallidized charcoal we are taking in quinoline. So we are getting what student cis, similar group, same size. This is cis. So this is what the what student that is the reduction reaction, right? Let me try to tell you the other one student what we can go. Addition of water. That is what we are going to study. Addition of water. Here also there are many conditions are there in H2O. Case one. Case one. Catalyst what is required is one H2SO4 and HgSO4. This one required. The first one and second one it undergoes tautomerization. TAT tautomerization. I mean both the cases student is going to give what carbonyl compound. Carbonyl. Right. This is going to give carbon. Now let us see the case one. If you are taking ethyne, right? It gives what? It gives aldehydes. It gives aldehydes. Case two, other than ethyne, other than ethyne. If you are taking other than ethyne, all gives what student gives. That is the point which you need to know, student. Okay. Let me tell you, if you are taking the ethyne student, here we are having CH triple bond CH, and you are taking the water student HOH. This is according to what it is going according to Markovnikov's rule. Always follow Markovnikov's rule. So what is going to happen? One hydrogen here and OH is going to be here. So it is going to be CH2 double bond CH and here is what is there student OH. Now it is going to be tautomerized student. Tautomerized. If it is tautomerized, this this is no accepting the hydrogen and this bond is sitting here student, right? So what is going to happen here? The CH3, this will be CH3. This is the ethanol student. Ethanol. Ethanol means that is acetaldehyde. Acetaldehyde. Now it is the acetaldehyde. Another things we are having case two. Let me tell you another CH3 is there. C you can take. So other than ethyne, all is going to give what student ketone. So let me tell you, here is HOH is there. Reagent is same. Hg2 plus I am taking H plus. Okay. So according to which rule? MR rule. If we are going to follow MR rule. So if you are following the MR rule, so this is the partial positive, partial negative. Negative charge goes to that double bonded carbon which have less number of hydrogen. So that is on second carbon, it's one student C. This is going to be OH. Then what is there will be a student CH. Now, dear student, what is going to happen? This is accepting this hydrogen and this bond is so this is going to be tautomerized. So if it is tautomerized, then what the product you are going to get? CH3, C double bond O, and here is CH. This is nothing but what is there. This is the okay. This is what the we got the reaction. Now let me tell you another one. What the other point which we are going to deal with student. If we are having this compound case 3, product should have product should have more alkyl group, more alkyl group. Whatever the product you are going, it should have the more alkyl group. Product must have the more alkyl group. That will be the acceptable score. So what we can do here, if I will take some other, okay, reactant CH3, CH2, C triple bond, C, CH3. So in case of this, what is happening, you can add the water molecule. So two conditions are going to be obtained. Two conditions. Either you can add the OH group on the second or on the third, because second and third are appears to be the equivalent one, similar. Both are having the same number of hydrogen. So where you are going to place it out? So let me tell you the both the condition. More alkyl group is preferred one. Student. More alkyl group. So first case on second C2 position, if you are adding OH, so what is going to be CH3, CH2. Here is the C, H. Here will be the what will be there, student? This is the C. Here is the double bond O H. Here is this is CH3. Now this bond will be shifting here and this hydrogen will be attached here. So tautomerized, after tautomerized, see the product CH3, CH3, CH2, C double bond O, CH. This is supposed to be major. More alkyl means methyl. Here, actually, this is not alkyl. This is alkyl, methyl. Means alpha hydrogen should be more. In other word, if you are going C3, so what is there? CH3, CH2, C. Here is OH. Now, friend, you can take CH and this is here the hydrogen will be accepted by this. This bond is sitting here. This is again going to be ketone only. CH3, CH2, C double bond O, this is CH2 and C. Here is no methyl group. You can see ethyl, ethyl are there. So this is the minor product because four alpha hydrogen are there. Four alpha hydrogen. Here is five alpha hydrogen. Five alpha hydrogen. So it is the major and this is the minor. This things you keep in mind, right? Now let me tell you addition of hydrogen halide. Addition of HX. If you are adding HX, student, vicinal dihal, no, it is not vicinal actually, it gives the geminal dihalide. What one? Geminal dihalide. Geminal dihalide. What is geminal dihalide, student? What is geminal dihalide? Geminal. Okay. Actually, the tab is not working so proper, so that geminal dihalides. So geminal dihalide means both halogen on same carbon. That is, if you are writing both halogens are both halogens are at same carbon. Both halogens are at same. That you need to know. Here, what is there, student? CH triple bond CH. You are adding the HX. So in first case, it can go according to any of the rules. Okay. First case there is CH2 double bond. What is there, student? CHCl. Now the second case, what we are going to follow MR rule, Markovnikov. And Markovnikov rule say that is negative part of reagent going to add with that carbon which are having lesser number of hydrogen. Here only one hydrogen. So X is going to be here and it is like that. So it is the CH3, it is the CH, this is Cl, this is Cl. 1 comma 1 dichloroethane. This is dichloroethane. 1 comma 1 dichloroethane. This is the first condition is there. Now what we can do here, let us try to add the HBr. Let me add the HBr. I am taking the another example. C, this is the triple bond CH, and you are adding the HBr. So what will be there, student? This is the Br will be here, and so this is the dear student. Let me tell you CH3 C. This is going to be Br double bond CH2. Then again you are talking about HBr. So if you are adding HBr, so this is Br will go according to MR rule, right? This is the MR rule. So if you are adding MR rule, so this is going to be CH3. See, here is Br. So again, what you are going to find, student? So both the halogen are the same carbon, na? So that is again going to be geminal dihalide. This is going to be geminal dihalide. Now, what we are going to go with the addition ozonolysis. Better you can try to ozonolysis. This is also important reaction. Ozonolysis, right? What is ozonolysis, student? That is two-step process actually. Step one, what we are going to be ozonide. You are finding ozonide, and step two, what is ZnH2O you are taking reductive ozonolysis, right? Now, dear student, let us see. We are having the CH triple bond CH, and you are adding the O3. So ozonide, how the ozonide here is forming, student? This is the CH. Now you add the oxygen. Here is oxygen. Here is the oxygen. Three oxygen are there. It is almost just like the alkene, but little bit different. Here is Zn is there, student, and water. This hydrogen going to be involved in the formation of H2O as a side product. Now see the other thing. This bond is splitting like that, and here is the double bond. Here is will be double bond. So what the product you are going to get? CH double bond O. So better we are writing in the systematic form so that you can be able to understand. H C double bond O. This is C double bond O, and this is right. So this is what the product. Now let us see next one. In case of higher alkyne, in case of higher alkyne, higher alkyne. If you are taking the higher alkyne, it gets oxidized. It gets oxidized with H2O2 to give A6. It is going to give A6. Let me tell you, this is we are having C triple bond C, and here is CH, and you are treating with us. So what will happen here, dear student? Triple bond cannot be break, so only double bond is going to break. One bond will be as it is, student. That is not going to be break. Here is the oxygen. This is the oxygen. Here is the oxygen. This is dear student. Here we are adding ZnH2O. So here is the this is the going to be out student H2O2 plus it is going to be out Zn, and now this bond is going to split here. It is here. It is here. So it is going to give two molecule of CH3 CH2. CH3 CH2. This is there. But here the condition is there, student. What is the condition here? This gets oxidized, student. Oxidized by what? H2O. So it will give CH3, C2 molecule, CH3, C double O. This is. So that also you need to keep in mind. Right. Let me tell you the another one. This is the oxidation. We study the ozonolysis. Addition of addition of X2 in CCl4, that is carbon tetrachloride required. Suppose we are having CH triple bond CH and you are adding the X2, student. So it is going to be CH double bond CH. Here is the X. This is the X. Again you are adding the X2 in CCl4. So this is the again going to N. So it is tetrachloro compound. It is going to tetra. Yes, this is hydrogen, 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 and hydrogen. Not hydrogen, actually, this is the hydrogen. Sorry, student. Yeah, what is this? X, X. So this is tetra halo. Let me tell you another one. Suppose we are taking CH3C and we are having C and CH3 and we are dealing with the Cl2. So what the compound you are going to get is here is the halogen going in CCl4. So trans in the first step it is going to give the trans LP. This is the trans because there is chlorine will repel inter-electronic repulsion. So how the product you can write, student? How you will be able to write the product? Here you see this is CH3, this is C. Here will be Cl, double bond C. Here is Cl, this is CH3. Friend, another thing you see. After that, what is again you are going to deal with the Cl. So now the normal LP. It is the CH3, Cl, here is Cl, C, Cl, Cl, and this is our required. Tetrachloro, right? This is compound is tetrachloro. Next one, let me try to. This is the X2 in CCl4. CCl4. Always we are talking X2 in CCl. This is exhibition of S2. This is the case one in CCl4. Now, if you are taking this one, case 2, okay. So, if liquid we are taking liquid Br2, liquid Br2. So, what the product you will be able to get, student? What the product you are going to get? That is the dibromo derivative. This will di. This will be dibromo derivative. This will going to give dibromo derivative. Let me tell you the CH. It can be CH, and you are dealing with the Br2 in H2, not CCl4, not CCl4. You are not taking CCl4. So the product you will going to achieve, student, here, that will be that is CH. Here is single CH, and here is this is the Br. Here is again Br. This is the Br. Again Br. Here is student 1 and 2. So it will be 1 comma 1 comma 2 comma 2. This is the tetra bromo and tetra bromo. This is what is the condition if you are adding the halogen, right? So almost we have done with all the properties. We are going to have the polymerization. So that is polymerization. We are going cyclic polymerization. Cyclic polymerization. it gives aromatic compound. What is going? It gives aromatic compound. Aromatic compound you must be knowing, student. This is aromatic compounds are cyclic compound. Now, suppose three molecule you are taking CH triple bond CH. So, you know, red hot iron TBW, red hot iron T. This is RHT. The temperature 873 Kelvin. So it is directly going to give what? This reaction can be better expressed in the term of like that, student. So three molecule you are taking. So what is going to happen, dear student? This bond is shifting here, this bond is shifting here, and this bond is shifting here. And this is the RHT, 873 Kelvin only. So what is going to happen? CH, it becomes the double bond, then it is single bond, then it is going to be double bond, then it is going to be single bond, then it is going to be double bond. This is what is the this is the case one. Case one. Polymer by ethyne. You are taking the ethyne. Right. Now the next case you see, student, next case, what the next case you can take, student? Case two. We are talking about case two. By propine. You are taking the cyclic polymerization of propine. So propine means what? That is, we are having CH3, C triple bond. How the product you are talking about the RHT, you are taking 873 Kelvin only. So this compound is going to be like here. This is. Now better you can understand in this format. CH3, this is going to be C triple bond CH. Similarly, we can have the look here, student. This can be CH3, C. Wait, student, we can write in the different format. Otherwise, the reaction cannot be possible. Okay. Here is the CH3 I am placing here. Another molecule I am taking CH, not actually CH, it can be the C. And here is CH3, triple bond, this is going to be CH. Then here is C, here is CH3, triple bond CH, and this is their student. Total hydrogen we have placed out, RHT. So one bond is shifting here, another bond shifting here, another bond shifting. So C, this will be going to be CH3. Here is the double bond. This is CH. Here is again CH, but here is the CH3. Double bond. Here is CH. Here is the what is going to be, student? CH3. Then it is double bond CH, and here is. So 1 comma, it is going to be what, student? If you are counting 1, 2, 3, 4, 5, 6. So 1, 3, 5, trimethyl benzene. This is going to be trimethyl benzene. That you need to know, student. How you will be able to that. Next one, we are going the next one. But we can do the next one is three. Polymerization of butane we are taking is 3. Butane. We are talking butane. So you see, student, butane, how can we do here? This is triple bond is there. Then triple bond. Then triple bond. What is there? RHT. 873 Kelvin. Here is this is hexamethyl benzene. This is what is called, student, hexamethyl benzene. Hexamethyl benzene. Now, you if you are not able to understand this one, it's not a problem here, not a problem at all. here we can I can explain you. See, this is again going to be CH3 triple bond. See, here is CH3. This is going to be CH3 triple bond. C, CH. One bond here, another bond here, another bond here. This is the RHT 873 Kelvin. So what will be there? Here is CH double bond C. Here is CH3 C. This is CH3. Here is C. This is CH3. This is C. Double bond C. This is CH3. Here is CH. This is again going to be hexamide, right? So this is all about what student we have done with the all the reaction of what that is the alkynes. So we have done the hydration, we have done the addition, we have done with the reduction reaction. That all we have already done today. So this is all about the today's class. Thank you very much for watching, students. Thank you for your